Okay, the question is the set of points on this line a subspace of R2? Now, this is an abbreviated statement of something you had in your hand. And it just, the question again is the set of points on this line a subspace of R2? Okay. Well, let's see. Can you give me the coordinates of a point on the line? Well, somebody said 0, 1. Well, yeah, if x equals 0, y equals 1, so the point 0, 1 is a point on the line. Can you give me another point? Well, people wrote down pairs of points. Well, just about everybody did that. So, somebody had the point 2, negative 5. Okay, if x is 2, then negative 3x is negative 6. You add 1, you get negative 5. So these are 2 points. Now, what we want to do is we want to check closure. Okay? So we're checking closure just based on 2 points. Now, if we find that these 2 points contradict closure, that adding these 2 points doesn't give us a point on the line, then we've proven that it's not closed. If they do give us a point on the line, we haven't proven a thing, except that there's at least one pair of points that add up to a point on the line. So we would have to go to symbols in order to prove it. It turns out, though, that this is going to be untrue, and just by using the specific coordinates of 2 points, we're able to disprove the assertion of, the assertion that this is a subspace. We're going to be able to prove it's not a subspace. Okay, well, of course, we treat the points as vectors now. Points are ordered pairs, and we can treat ordered pairs as vectors, so that when we add them, we just add their coordinates. So 0, 1 plus 2, negative 5 gives us 2, negative 4. 1 minus 5 is negative 4. 0 plus 2 is 2. Okay? Well, that point isn't on the line. How do I know it's not on the line? Well, this says that when x equals 2, y is negative 4, right? But if x is 2, we can see that y is negative 5, right? If x is 2, we get negative 6 plus 1. So y equals negative 3x plus 1 equals negative 5, not negative 4. So if x equals 2, this is negative 5, not negative 4. So this example alone shows that the operation is not closed on this set of points on this line. So the set of points is not a subspace. Okay? And we could even more easily have checked closure on scalar multiplication. Is c times 0, 1 on the line? Okay, well, c times 0, 1 is 0c. Is 0c on the line? Well, not unless c equals 1, because the only x equals 0 point on this line is y equals 1. So it's the point 0, 1, the point we already have. So 0c is not on the line for most values of c. Now it is if c equals 1, but otherwise it isn't. So we can't say that this thing is closed on scalar multiplication. So if we were looking for a quick way to disprove it, this is probably a little quicker than this, but it helps to do both and understand even more clearly why this set of points is not a subspace. Okay? Now, the problem said, okay, show that this isn't a subspace, but this is. Set of points on the line y equals negative 3x. Now, if we're going to try to prove that it is, we'd better not try to prove it just by choosing the point 1, negative 3, or the point 0, 0. Okay? 0, 0 would be a really bad point to use because it has special properties, since multiplying by 0 gives you 0. Okay, well, we have to use symbols. So what symbols could we use? Well, we're going to let, and I just, I waited for somebody to say something, said, okay, a, negative 3a would be a point in the line. That's symbolic. That could stand for any point on the line. And so could b, negative 3b, right? So if a, negative 3a, and b, negative 3a stand for 2 points on the line, could be any 2 points, we can check for closure under addition. Okay? So what's a negative 3a plus b negative 3b? That's a plus b negative 3a minus 3b. Okay, what's that equal? What that equals that equals a plus b negative 3 times the quantity a plus b, just simplifying this by factoring out the negative 3. Okay, is that on the line? Well, this says that x is a plus b and y is negative 3 times a plus b. Well, that alone says that y is negative 3 times x, and that's the condition for being on the line. But let's be careful and write it out. Okay, if x equals a plus b, then y is negative 3x, which is negative 3 times the quantity a plus b. So the point a plus b, negative 3 times a plus b is on the line. Okay, there's a proof. And we had to use symbols. We couldn't use just a simple example, a single example. Okay? Now, I want to show that we can combine the test for closure. We didn't check closure on scalar multiplication, did we? I kind of leave that to you, but it's equally easy to check. There's a single test that can replace both the tests for closure on addition and closure on scalar multiplication. And in most cases, that test is easy enough to verify, just about as easy as verifying either of the other two. So since it gets both of them at once, it's very useful, but we have to be sure that it works. So I'm going to say that if C1V1 plus C2V2 is always in the subspace whenever V1 and V2 are, then we have closure under scalar, under addition and scalar multiplication. So I'll explain that next.